Hello, my name is Beth Dixon, and we're going to be doing lesson 2, problems 9, 10, 11, 12, and 13, or an example that'll help you get through those questions. And this is most like question 13, a little bit different. And we're going to be talking about how to do the word problems. In the word problems, the first thing you want to do is be sure that you draw a picture of your triangle. And as you draw a picture of your triangle, you want to be sure that you mark your hypotenuse and your legs and then solve. As we do this particular example, before I get to this particular example, remember that as you do these, there are two methods to solve. You're either solving for the hypotenuse or the legs, so you can go back and review the previous video on how to do those. So let's look at this one. TV screens are measured on the diagonal. That should be a period there. Due to his furniture and layout in his apartment, Alan measured 66 a space, I think it's supposed to say, 66 inches long by 54 inches high to place a flat screen TV. He needs to leave 2 inches on all sides for edging, for space around it. So how large of a screen can he purchase? And can he buy an 85-inch screen TV? So that's the setup we have. So let's first draw a picture. In this case, we have a rectangular space and not a triangle. And our rectangular space, which will not be to scale, is 66 inches long by 54 inches high. And we need to leave 2 inches of edging. So around here, we need to cut out and leave edging. Maybe the 54 inches went all the way up to the ceiling and we can't go to the ceiling. Maybe on the bottom there's furniture and we want to be 2 inches off the furniture. Maybe there's a piece of furniture here and a wall here and we want to be 2 inches away from there. So that means this right here is 2 inches. This over here is 2 inches. So that's 2 inches here and 2 inches here. So that's 4 inches off of the 66. So that would be 66 minus 4, because we're taking 2 inches off here and 2 inches off here. So from here to here would be 66 minus 4, or 62 inches. The same thing for the 54, because there would be 2 inches here and 2 inches here. 2 and 2 would be 4, so that would be 50 inches inside. So when you do a 2-inch edging, it'd be 2 off the top, 2 off the bottom, 2 off the left, 2 off the right. So our new numbers are 50 and here. Well, we also have something else, which is we can only do things with triangles. So with the triangle, what we're doing is a diagonal, which goes down here. Now that's a lot of numbers and a lot of things going on in that little bitty picture over there. So let me redraw it. We have a height here of 50, a length of 62, and a diagonal that measures the diagonal of the screen, and that's the unknown. Here is our right angle. That makes the unknown my hypotenuse. And because the unknown is the hypotenuse, and I've got room over here that you can see, I'm going to come over here and go c squared equals a squared plus b squared. And in that case, my c squared is the unknown. I'm going to label one of these a, the other one b. My a squared is 62 squared plus 50 squared. And then I'm going to just take my calculator and come down here and do 62 squared is, so that's c squared equals 3844 plus 50 squared, which is 2500. So c squared $3844 plus 2800 is 6344. And then remember, we take the square root of both sides. And the square root of 6344 is 79.649. So we can buy up to a 79.6-inch screen. So can we buy an 85-inch screen? No, we don't have enough room. We might squeeze in an 80-inch, but that does not leave us the full 2 inches of edging. So you would have to then decide. So we would be better off with a 65-inch or a 70-inch or a 75-inch screen TV. And that's how you interpret the problem. Notice that we did draw pictures, we wrote words, and then we applied the Pythagorean theorem. And as you go through that, those are the steps that you use. Draw your picture, draw your triangle, label your triangle, write your Pythagorean theorem, plug in your known values, and solve for the unknown.